In this equation that we see here, ax plus by equals c, I'm going to talk about standard form for this application problem. And it says here, you are running a concession stand at a basketball game. You're selling hot dogs for $1, and you're selling pop for 50 cents. At the end of the night, you make $200. And part A says here, write an equation in standard form that can be used to find out how many hot dogs and how many pops were sold. Be sure to define your variables. So I'm going to start talking about my variable x and my variable y. Now, it technically doesn't really matter here which one you call x and y, because hot dogs and selling pops, it's not like selling pops depends on how many hot dogs you sell, and it doesn't really matter selling hot dogs depends on how many pops you sold. So really you could order your x and y just however you want. But since I was told hot dogs first, I'm going to call it x. And since I was told pops second, I'm going to call it y, just because first in my function is x and second in my function is y. But again, the order here won't matter because I don't see a true independent-dependent relationship happening with these two specific variables. So I'm going to let x represent the number of hot dogs sold. And I'm going to let y represent the number of pops, like pop cans that were sold. And then it says write an equation in standard form. I want to make sure that I do that. So the cost per x hot dog is $1. So ax, or 1x, plus 50 cents per y pops, so 0.50y. We want to find out when that will equal our total amount of our C, our constant, the $200. Now in this equation, I don't really need the 1 in front of the x, so I'm going to erase that because I know that just the letter x is 1x. That 1 is kind of unnecessary. Now that I have my function here in standard form, I'm going to solve for the x-intercept and the y-intercept. And that's really why we have standard form, because it is the most useful form for quickly finding x and y-intercepts. So that's why we didn't ask you for point-slope form or even slope-intercept form for this problem. So if my x-intercept is going to be an x comma y, and if it's an x-intercept, I'm solving for x, I'm going to use my function and I'm going to plug in 0 for y. Some teachers call this the cover-up method, and I'll show you why they call it that method. If I were to plug in 0 for y, this term completely goes away from my function. So I'm going to try to, just cover that up there. If x was set equal to 200, because this term here got zeroed out, what would my x-intercept be? Well, that's really easy. It would just be 200. So that's why the cover-up method is awfully useful. So in this equation, if I put 0 in for my y, this goes away, and I have x equal to 200 hot dogs. If no sodas or pops were sold, so that would mean if 0 pop cans were sold, it would take 200 hot dogs to be sold to make that $200. So x-intercept, meaning no y's, I need 200 hot dogs. So I'm going to put my 200 there. So there's my interpretation. And now exactly opposite of that, if we were to only sell pops, so opposite, because if I'm finding a y-intercept, that means my x was 0, and I want to solve for my y. So if my equation was x plus 0.50y is equal to 200, and my cover-up method says if I were to zero out my x, if that was 0, not there, if 0 pops were sold, and I only sold my 0 hot dogs were sold, and that goes away, how many cans of pop were sold? Well, I need to divide by that coefficient of 0.5. So I'm going to take my calculator out, and I'm going to take 200, divide by 50 cents, and I get 400 cans of pop. So y is equal to 400 cans of pop. So I found my y-intercept, that's this here, and we found our x-intercept there. So now my sentence will be, for my interpretation, if 0 hot dogs were sold, it would take not 200, but this time 400 cans of pop to be sold to make the $200 they made for the night.